Okay. All right. So good morning again. I'm now recording. So I have to start all over again somehow. There's a need for vertical curves, and I'm going to ask one of you to tell me why we need vertical curves. We all understand that horizontal curves exist, or in a planimetric view, it lies in a horizontal plane. Are you okay? But then, why do we need to also consider verticality? Why should we look at the vertical curves which exist in the sectional? When you look at our road from the section, we will see that if we cut the road, okay, if we went through the all right, and we decide to actually look into it this way. I don't know if I put a symbol for section. I got it right. So we're looking at this. Then we are going to see that either it's a straight line, okay, the center line, the top is straight or it's curved, all right? But who made it that way? The designers did, okay? And we're learning the idea of design. Let's justify why we need to put in a vertical curve, okay? So this question goes to the students. We've understood every reason why we need to put in a horizontal curve, i.e. to avoid, for safety reasons, considerations, okay? Not having an abrupt change, okay, of direction, okay? And naturally, we have to avoid obstacles. So we don't have choice. What obstacle are we avoiding? Is there a bird flying in the sky? Let's have a good laugh. You know, there's no bird in the sky that we're trying to avoid that we have some. Are we seeing what I'm saying?
Yes.
Okay, great. So then why do we say we need? So let's have a submission from the students. Those online, you can contribute. I switched off my volume. My volume was low, so now I can hear you. If you're online, only 2 people. Let's take 10 minutes. Remind me. Okay, so why do we need to put in a vertical curve? Let's have a chat, guys. Let's have reasons for
So putting vertical curve to have a especially on the continuous areas of the track.
in comfortability. Yes, yes. That's one word. Why?
So because when
That's what for comfort. Okay, because can you imagine if you went up
very steep,
and then all of a sudden you were dropping? What else? So that's one. Maxwell, your reason if you're the only one on earth and you wanted to do this kind of thing, and once your wife said, "Don't do it," you know, don't do it. What would be your excuse that you think you should rather have a kid? She'll tell you, everybody knows what to do, so stay in the house. What would be your choice? How many of you realize that I ask questions that I ask in class sometimes? So try and let's do this. Yes. Yeah. To the same considerations,
This to allow you to continue your journey.
for safety.
comfortability, safety.
Giving clear.
Yes.
The safety.
Anyway, we'll talk about it. Yes. And I don't have a lot of friends, you know. I don't have a lot of friends.
You have a
Friends.
Because of the
I'm my only friend now. Okay, so obviously I think you're right. Comfortability also got something to do with safety, but let's differentiate between them. You see, because sometimes you're not comfortable, but it doesn't mean you're safe.
Yes.
The fact that you are also comfortable doesn't mean you are safe. Like we can just swap around. Comfortable that doesn't imply community doesn't imply safety. Do you agree?
Yes.
Because we all drive cars, but you sit in a certain car and you wonder, how did I get here from Kaswa to here in like 2 minutes? Like you are sleeping because you are in a 4x4 with some good shocks. You sit in some cars. Oh my God, it's like I'm traveling. because you're not comfortable. Are you okay? So comfortability should be 100%. Are you okay? All right. So you realize that safety comes in here in terms of the line of sight between the driver in this car and the driver in this car facing you. Okay, we have lanes, but you all know that people don't necessarily drive their lanes and cars overtake each other. Again. All right. Now, common sense tells you that if you don't know what's ahead of you, there could be anything ahead of you. And people have died on the Accra Kumasi Road. I've told you guys I'm a melancholic. I get quite sentimental when I teach. I've told you that, haven't I? All right. And so someone is saying it means he's going to ask a question about it. I may never ask a question. I guess sentimental when I'm talking about it. All right. So we see that if I don't know what's happening here, that alone is scary. Are you with me? Because initially you look up and realize that there is no car approaching. And then all of a sudden, welcome to heaven. Are you okay? Like you died. Because there's a collision. And why do you have a collision? Simply because you couldn't see ahead. So all things being equal, if I was the only engineer left on the air, I will make sure that we don't have any slopes, guys. All roads will be flat. So I'm going to cut all the mountains. I know. I will. But let's tell you what they do a lot in the UK. They don't mind cutting trees. A tunnel. That's one of the reasons they have tunnels. To just avoid the slopes. Okay. So it's up to you and what you do. I love engineering. The fact that sometimes there are projects that are just expensive. Cost, we're thinking cost. But I'm thinking what?
Say in that no costs. I think they also have done a lesson about it. Let's say the kind of fuel value of this
so there's a cost benefits analysis. Okay, I think I'll take you to the master's class. MS. Okay, I'm coming. Just a second. Okay, please remind me to take attendance. Okay. Because I see online and I have one person. So safety considerations are important, right? And I said that I wish I could get rid of it, but we can because of cost benefit. So either way, you can justify why you should have it or why you should. But at a point, you will need to just have it because it's not all the time that you can even do it. It's not all the time that you can even afford to even like pull this whole thing off because you don't have the money to fuel your bulldozers to clear it. So what if you were stuck with just making a vertical curve? Then you have to do it. Is that okay? Now, safety considerations come in terms of, like I said, the sight when you cannot see it. Are you okay?
Yes.
All right. So sight distance is literally the distance from here. It's like based on if you have a height h, so that if the driver is sitting at a height h, so if the driver was in a huge car in which his eyes are here at this point, then we draw a line such that he almost sees this car. Are you on the same distance? Same distance. Now the distance, the side distance then becomes s from here. This is the story of side distance. Okay, now this point here, where we having the intersection or the tangent point is meeting where the car is only one case. Okay, so you can have like 3 cases. You have a case where you have the curve, right, going that way, but then the side distance is somehow bigger, longer. You have side distance S, which is greater than the length of the curve. Are you okay? Right? Okay, so per the notes I've used, the reference I've used, the whole class, you agree that from here to here, we call it L, and we call this one L. Okay, so we are using Bannister's approach. Right, so if you have L, you have L, then the total length then is what? 2L. Okay? So in this particular scenario, S is greater than 2L. So the formula that will be used for S equals to 2L, and the formula that will be used for S greater than 2L and S equals to 2L are different. Are you okay? So S is the side distance. Are you okay? All right?
Yep.
All right. And so you can have another scenario where we have the side distance being less. So in that case, then it's in there like that. Can you picture these things like in real life? So L, S, 2L. So S is less than 2L. Okay? So there will be 3 different formulas that can be established. Okay? And why are we interested in the side distance? Because it's got everything to do with safety. Should the side distance be longer? Should it be shorter? What are the implications of longer curves, longer vertical curves? What are the implications of having a longer? Do you want a shorter vertical curve or a longer one? And why? Obviously, we all know that if it takes a long time for me to see him,
the safety becomes a problem.
Okay, what if it takes a short time for me to see it on the other side? Which one do you prefer?
I take a short time.
So with this one, let's use home sense.
Yeah.
Exactly. I think what most of us drive or have driven.
The shorter.
If you are going from Kumasi to Accra, would you love that you quickly see the other side, or you actually see the other side? It takes a long time for you to see what is happening on the other side. If you've driven before, this one is a natural, something that you will know. Which one would you prefer?
I think
feel free. Don't influence.
Long time distance. The rest also relax. Like I can see far. So some of them they don't pay attention. But if the distance is also somehow I know that okay. After this, I'm going to be active.
The safety is at risk here. So if you observe the opposite driver in a longer distance.
Let's say the extreme case, like this one's very steep.
This is steep.
You realize that if you go in this way, all right, then your side distance then has to happen somewhere up here because the nature of the system.
So that one becomes the short or long one. That is what I was imagining. If it is steep, then does it become the short?
So now we have 2 things to compare: the length of the curve and then the side distance.
The length of the curve and the side distance.
So would you prefer a longer curve or a shorter one? Like, do you know which one of these scenarios to be when you are here? It means the car is here.
Yeah.
Side distance is the driver's eyes seeing.
Yeah.
That's what. And that horizontal distance. That's a step. Immediately you can see this. You have a side distance. Okay. So we assume that this is symmetrical. This curve is symmetrical. You get it? All right. So would you prefer you being up here? Okay. A longer curve, a longer curve, or shorter curve. There are different combinations. In terms of safety, let's just talk about our driving things. It will help us. Prefer
the side distance is greater than
the length.
Yeah, very clear. Yes, and your reasons are because then you know what is happening at the end way longer. Yes, I think that scenario seems to me. Oh, as was just feeding there, you can always
You know that
this is what's
about 100
yes.
meters is clear,
Yes.
or something is coming about 100 meters. You know how to say yourself in the
Yes.
And also from the driver's other side.
and you know, if it is misbehaving, he has run up or going left, right, center. You know
Okay.
where you position yourself. But if it is the curve is longer than the side distance, very risky.
Well, we are going to travel on a normal.
Okay. Okay. So you can have that discussion. Continue that discussion. Maxwell. Sir, please kindly record a call and your internet is not stable. 10:47. What time is it? Okay, it's a long time. Okay, but basically, please, I want you to understand these basic diagrams. Okay, appreciate it. The most important thing to know as an engineer is the gradient. Okay, what's the so the gradient is like the slope. So the word slope is also referred to as the gradient. Right? It's a change of vertical distance with respect to what? Horizontal distance. That's all there is to it. It can be expressed in percentage, so you can have 2% slope. Okay? In fact, roads and highways department, okay, highway department, always prefer that you don't go beyond a certain percentage of slope. So 3%. There's a maximum. And of course, sometimes it depends also on whether you're on a motorway. Are you okay? So motorway 3% gradient for slope. Do you understand what that is? We are going to talk about it. So the gradient or slope is what we always want to be like this, changing y, changing x. Really, this is slope in math. Okay, it's the same thing talking about. So here we have rise, we have run. Are you okay? Engineering. Are you okay? Also horizontal.
Running. So running is not going.
Same.
Running is the same as going.
You can go for that. Sometimes technology change. So we can, but what we will refer to is the horizontal distance. Okay, so how much have we moved, are you okay, in terms of horizontal, and how much have we dropped? Are you okay? So one, and I would say 1 in S, that means that 4. I drop 1 every S distance of S. And that is the one going on horizontal. Whether you're American, Canadian, different words are used, but the idea, are you okay, is to now find a relationship, are you okay, between a change in your height. So when we are in this room, there's no change in height. Literally, you don't have any slope going on here. Because as I move 1, I don't drop. Are you okay? So delta y is 0. In fact, I don't intend to use delta, it's not right. I'm just trying to bring your mind from math for those words. Okay, so 1 in S of a slope, in terms of percentage, what is it? 1 in S. What will be the percentage?
1%.
So it means that I drop 1, I move S, so that's more like, yeah? Drop 1, changing S, that's to change Y. That's so you don't work out the ratio. That's going to be like 1 S. Then of course you have to multiply by 100, isn't it? To be 100%. So literally that's 100 over S in terms of percentage. Instead of putting S, if you said P, then you can just do the same thing. Let's call algebra. I just use variables to actually represent real life, okay, values, generic idea. Online people, we are going off in 10 minutes. Please rejoin. And I hope you are even following what we are doing. Because I think what you are seeing on your screen is just same things. Okay. All right. Please, I hope we are quite clear on this one. And gradients that are, so the slope, the gradients, is what we are referring to here as this ratio. Okay? Gradients that are rising to the right are positive. Gradients that are rising to the right are positive. So if I go like that, from your left to your right, that's a positive gradient. Okay? And also the left hand gradient is represented by P in this class. So
The
for
left
what I'm
hand.
teaching, the left hand gradient. So if you have two, you always have two, isn't it? So the left hand one is P, it's rising from the left to the right is positive. So positive P%. Right? Then we have going to from left to right falling. We have negative Q. Of course, the Q goes. Okay, take note. This is just something we have to take note of. There's no need to ask why and all these kind of things. It's a convention. Are you okay? Convention. All right. Now let's look at about 4 or maybe 6 if you want to understand it. Ways that we can have curves. We can have curves in very, very interesting configurations that we are going to look at, but they are not complicated. All right, so that's one of them. Are you okay? Right. You can have a situation where you have positive gradient and you have another positive gradient. So in the real world, it's interesting. So P percent positive, Q%. Of course, you get your curve in this. Okay, so we can have a situation like that.
So as far as the gradient is rising, it's positive.
As long as, if I look at this one very carefully, the only time when it becomes negative is when you force to lower this horizontal. But it's just a sketch. So I'm being a good artist to make sure that you understand what I'm saying. So literally, if I did this and I dropped it a little bit, this would
Become negative.
become negative. Okay. Because then it's dropping. So the drop only happens below the horizontal. All right, so we can have so many scenarios. You can have one that looks like this. All right. Yes, you dropping in there. So this is where I enjoy when someone is driving me and you're doing now.
Just leave your leg.
You see what I'm saying? Then you are out of the. Okay, so this point up here, this is actually a crest curve, or if like a summit. Please take note that it's not only the UK and not, or the Americans or the Canadians, and you can't really attribute knowledge, any particular country to have all knowledge, a repository of all knowledge. So the words are being used, interchangeably sometimes. Crest, sometimes summit. Now what we have here is a sag. It's a sag curve. Sag curve, crest curve. Okay. All right. So here, now this is negative or positive. So this is negative. So negative P and positive Q. Okay. So you can have that. You can also have two negatives. So use this one. Oops. Okay. You can have that. Okay. You can have negative P, okay, so you can have a curve. Sorry, I'm not really following. Beautiful art here. Sketches. So if I can have even two more, so you can try it. Try and figure out the extra two curves from putting here. Okay. Yeah. I think you're in a price extra. You can have extra two curves.
in the curve.
No, like these are 4 different configurations. Positive P, negative P, negative P, positive Q, negative P. They give you different configurations of the curve. Here you are dropping away, here you are dropping and still dropping. Again, the road is still continuing like to drop. Are you alright? Here you go up the slope and then you just drop down. Are you? Alright, and then here you just keep going up and up. You are still like on the curve. So let's understand that. Okay. So the next thing to look at then is the differences, the algebraic difference in gradients. So algebraic difference is just subtraction, the difference between two values is subtraction. So here we can have P minus Q, which is P plus Q. So the net effect is a positive value. Let's look at this one. P minus Q. Okay. All right. So we positive. Let's look at this one. Negative P, negative Q. Okay. Literally, this is more like P plus Q. Negative. So the net effect, the gradient is negative. Okay. It's negative, but we are really summing the gradient. Okay, for this one. So negative P minus that will be plus. And so you can always add up these values, and then you will now have different values in terms of the aggregate slope. Okay. So comfortability. Let's touch on that a bit. Comfortability. To the engineer, what's the comfortability, please? What's the physics of comfortability? I think we forgot to touch on that. Your name again? I forgot. Isaac, Christopher, Chris. Comfortability, engineering point of view. I think you're talking about political point. To an engineer, what's the physics of comfortability? How would you answer a question in the exam and kill it? Comfortability. What's the physics? Online, time is almost up. So rejoin, okay? So let's answer that when you come back. Someone says something. Let me say, please, I can't see what you are writing at the lower part. Oh, I see. Sorry about that. Can they even see the board? Sorry about that, guys. I'll try and let you see it, okay?